Good afternoon. I welcome all of you to the 35th lecture of webinar series of the Archaeological Sciences Center, IIT Gandhinagar. And I also welcome all the participants who have joined online. Today, it's going to be a hybrid session because we have with us Professor Krishnan, and he will be delivering the talk here in a hybrid mode. I welcome you, sir, to IIT Gandhinagar, and I thank you for sparing your valuable time interacting with us and also consenting to deliver the talk. So I think Professor Krishnan doesn't need any introduction, but as a customary practice, I request Unka to introduce Professor Krishnan, and after that, the lecture will be started.
Welcome everyone to the 35th lecture of the ASC webinar series. For today's webinar, we are privileged to have with us a scholar whose expertise in the field is truly remarkable. Professor Krishnan is an emeritus professor and a distinguished faculty member from the Maharaja Sayajirao University of Baroda. Currently, Professor Krishnan also serves as a guest professor right here at IIT Gandhinagar. He will be delivering the talk on viewing ceramic thin sections, methods, and prospects. Professor Krishnan's contribution to the study of protohistoric and early historic ceramics through the integration of traditional archaeological, ethnographic, and scientific methods is profound. These studies have enabled us to work towards understanding craft specialization, development of technology, and its impact on ancient South Asian society. These studies have inspired several students from South Asia to conduct research on South Asian ceramics. In addition to this, his work towards appreciating and reconstructing the paleoclimate in central and western India, he has completed several research projects dealing with the ancient technology and paleoclimatology and currently involved in 4 ongoing projects in Sri Lanka and Nepal. He also coordinated a project which established a museum at Sidhpur, a center of pilgrimage for the Department of Tourism, Government of Gujarat. Before we embark on this enriching journey of knowledge, I would like to extend our heartfelt gratitude to Professor Krishnan for gracing us with his time, insight, and wisdom. And now, with further ado, I kindly invite Professor Krishnan to please come to the dais.
First of all, let me thank the organizers of this session. This particular presentation, I'm planning to discuss how ceramics studies have been done in a different way. Ceramics, as all of you know that, it is one of those chronological indicators which archaeologists use. And more than that, I should put it in a different way that ceramics have been glorified to such a level because it has become extremely difficult to speak about settlements and settled communities without looking at the ceramics, because it tells you the nature of life, the kind of changes that have been taking place, and also about migration, diffusion of technology, and many other cultural processes can be understood by looking at the ceramics. But my approach to ceramics is from a very different point of view. What I do is that I look at the thin sections, that is a transparent section. Right. So this is what the definition of a ceramic thin section is. Actually, this is prepared from a ceramic piece. On the left side, you can see a ceramic piece. On the right side, what you are seeing is a thin section. So on the left side, you can see only plain surface, whereas on the right side, you see lot of grains. These are primarily sand grains, and we call them as non-plastic inclusions, and also some people call it as tempering material. See, why do we call it as non-plastic inclusion? It is because clay is a plastic material. If you mix it with water, you can shape it into any form. Whereas these materials are non-plastic materials, their form doesn't change. And they may be present in the clay, in the raw material deposit itself, or it needs to be added. Or if it has more amount, it needs to be separated and some part of it has to be retained. There is a reason for that. The definition of clay, as per a sedimentologist, is any siliceous particle whose size is less than 2 micron can be considered as clay. In its chemical formula, it is aluminosilicate hydrate. So when you heat clay, it undergoes certain changes over a period of time as the temperature changes. It contains 3 types of water: the hygroscopic water, then the absorbed water, and the lattice water. This hygroscopic water escapes when you heat it above 50 degrees Celsius, 50 to 80 degrees Celsius, it goes off. And the absorbed water goes off somewhere around between 100 to 150. And the lattice water, which is present in the clay crystal, which is a part of the clay crystal, that starts disappearing from about 350 degrees Celsius to say around 700 degrees Celsius. So if you make a ceramic or a vessel, a pot from pure clay, it is bound to shrink and crack once this particular lattice water starts going out, because it will develop stress and strain. So what the potters do is that the potters have to make it porous. So when it is made porous, through this porous area, the lattice water goes out, so that it does not undergo any kind of shrinkage or anything of that sort. So those are the materials that you are seeing there on the right section. And it is basically sand particles which are present within the clay or which are added later. Now, we have to have an assumption when you start doing ceramic analysis. Like when archaeologists do ceramic analysis, the first step that they do is categorization. They look at the similarities and differences, and they try to sort them out. Secondly, they try to define the groups. They try to make it into red ware, buff ware, or gray ware, whatever the ware. That is, you are studying certain attributes and bringing all those attributes together and bringing it into a group. And the third kind of study, that is characterization studies, which is done in 2 ways. One is through mineralogical approach. The other one is through chemical composition. So here I am going to present the mineralogical approach. And similarly, the assumption is very similar to that of the archaeologists. Something is masking there. So whenever you are studying ceramics in archaeological context, we consider, even if it is a broken piece, we think that it represents a whole culture or it represents a full pot. Similarly, when you are taking a ceramic thin section, your assumption is that there is a homogeneous distribution of grains within the clay within the vessel. So a ceramic piece which represents either the whole vessel or a set of vessels, because some of the workshops collect clay from one particular area and they follow a particular tradition of making. So even the whole work process gets reflected there. And or different processes also get reflected. Then you can say that the thin section represents the composition, and it represents the whole vessel or the vessels made from the same clay or different raw material from a single or a multiple workshop or workshop complexes. Because in certain societies, there are certain restrictions with regard to exploitation of the raw material. Certain societies do not allow exploitation of raw material from everywhere. There are select areas from where it is exploited. So certain workshop complexes may be exploiting it from the same place or maybe 1 or 2 places like that. So the primary assumption, this assumption is very important, and we have arrived at this assumption by looking at the ceramic section from, if you take a big jar, the rim portion of the jar and also the base portion of the jar and also the middle portion of the jar were studied, and we found similarity in the mineralogy overall. It might look a little different when you see the photograph, but compositionally they are the same. That is why it is assumed that a ceramic piece represents a whole vessel. Now, the goals of doing this petrographic or thin section analysis, One is to determine the provenance. This is very important because when you look at the archaeological information that is available, some of the ceramic types may not be represented in the cultural milieu in high quantity, or they may be of a special quality. So the archaeologists might tend to propose that they have come from somewhere else. Now, that proposition need to be tested by looking at certain kind of composition analysis. That is why we do provenance analysis. Second is preparation techniques of clay paste. We have different types of ceramics. In broad, we can say the fine and the coarse ones, and the ones which are falling in between, we call it as medium ones. So when you look at the paste texture of the coarse one and the fine one, you can see a massive difference. Similarly, within the fine ones and within the coarse ones, you see a lot of differences. These are all primarily speaking about the kind of preparation techniques that was practiced by the potters. Now, shaping of the vessel to some extent is also possible, but I have put a question mark there. The reason is that I had done a lot of ethnographic work when I started working with ceramics, and I noticed that the potters use more than one technique to prepare a vessel. So it is mostly multiple techniques. But in general, archaeologists have a tendency to believe that if you see parallel striation marks on the surface of the pot, it is a wheel made. But it's not necessary that it is wheel made. In general, if you look at when you work with potters and all, most of them do not make a vessel whose size is or its height is less than 1 foot, because that is a workable or convenient size that they can. Then what they do is that they beat it around and they enlarge it. So that particular kind of time, what happens is that it gets it's another technique that they are doing. One is wheel throwing, then it is enlarging the pot. So there is a general belief that if there are longitudinal particles within the thin section, and if they are taking a parallel orientation, it can be considered as a indication of wheel making. But that wheel making part, that also disappears when they expand it further. And so I feel that ceramics were not made by a single technique. Mostly multiple techniques were used when you look at the specialized ceramics and all. Then intersite and intrasite variations and similarities. It may look the same, but it may be compositionally, they may be different. They may be coming from two other sources. That is one. So within a site itself, you can have ceramics coming from different places or different workshops that are manufacturing ceramics. These are all possible when you are studying large sites. For a smaller site, it becomes slightly difficult. Then chronological standardization of ceramic microstructural features, which is a very difficult and very important work, that if you have a kind of a trench which has some 6 or 7 periods, which has some 40, 45 layers, and if you collect ceramic samples from all these 47 layers, and if you try to look at their thin sections, and if you can define the thin section, you will have to develop your own methods and you will have to have your own parameters to define those things. And once you do it, then you can see how slowly and steadily the technological process or the manufacturing process was advancing. So that is the last one. Now, if you look at the history of this particular field, this is not very popular in India. It is not very popular in many other parts also. There are certain reasons for that. Actually, the first person who thought of looking at the ceramic sections, that was in the late 19th century, a British geologist. He looked at the ceramic thin sections, and he was a sedimentologist, so he started interpreting them from a sedimentological point of view. His descriptions were like that. And then there was another person called Miriam Welker. She was one of the participants in the Tepeyahi excavations. And she started looking at some of the thin sections, and she just gave a description of the minerals found there and also their distribution pattern and all those things. Then Anna Shepherd, when she wrote her book, that Ceramics for Archaeologists, she mentioned this as one of those very important techniques that can be used for studying provenance analysis, and also that can be studied for understanding the techniques of production, in general, the technology, and also try to understand the evolution of ceramic technology, etc., etc. So she mentioned it. That book was published sometime in 1940s. Then there were many people who were working on Roman ceramics and all those things. And now it was somewhere towards the late 50s that one person started working on the Roman coursewares. And that site was located in a contrasting geological formation. So as a result of which he could see that he could group them into different petrographic groups. That is, petrographic group is a term that I am using, means the grouping that is done using petrology. So I call it as petrofabric, because I don't use the term fabric, because the term fabric is used by archaeologists in many other way. So here that there should not be any confusion. So I'm using the term petrofabric, which means the tin section, when it is grouped together based on their composition, that is known as petrofabric group. So he had a contrasting geological formation. So as a result of which his work was successful. The person is Professor D.P.S. Peacock. He is nowadays he is no longer now, no more. Then afterward they started reconstructing ceramic technology, that is especially the paste preparation techniques, and they started looking at the coursewares, and based on the textile parameters, they were able to say that, okay, this may have been the process through which the clay pastes were prepared and all. But then in Indian context, you cannot superimpose any of these models because we have mostly fine wares. And majority of the celebrated pottery of the Indian context, especially if you look at the Harappan period, or if you look at the early historic period, the deluxe wares like NPPW or PGW and all those things, you do not have these kind of larger inclusions in that one. And also it is extremely difficult to work with that. So it was extremely difficult because the fine ware petrography is fairly a difficult job. Mostly because of one reason, because when you are looking at the ceramic thin section, its thickness is 30 microns. So you can measure the optical properties, or you can recognize some optical properties, and you can also study the grains whose size is above 30 microns. And below 30 microns, that forms a part of the matrix, which you cannot study. But whereas in case of NPPW or in PGW and all those things, mostly the grains are lesser than 30 microns in size. So that becomes a very difficult thing. So we had to develop our own methodology for that. Now, there was also another kind of change that was taking place in the ceramic petrological studies. That is, earlier, the first one about whom I mentioned, that he was a geologist, so he considered it as equivalent to sedimentary rock. And of course, criticisms emerged because the man behind the artifact has to be understood. That was in the 60s and 70s. Then it further advanced that the human hand and skill in early 80s. And of course, people thought that even the mind of the craftsman can be understood, that is in late 80s. And the complexities in social order, that is recent. We are all trying to work on that, but it is not that easy to say anything from this ceramic thin section analysis. But still, we are trying. Now, if you look at the other kind of development, that it started as a simple fabric description, then it was oriented towards the provenance analysis, then it was oriented towards the textural analysis, and also methods of reconstructing the paste preparation techniques. Then it was oriented towards resolving archaeological issues such as exchange, long distance trade, spread or diffusion of technology, etc., imitation of technology, innovation, etc. Now, when you look at that exchange, long distance trade, spread or diffusion of technology, etc., you cannot explain these process only from the ceramic thin sections. You will have to incorporate the other archaeological information. Then only it can be, explained. Now, this is something which is which is quite important actually, because people think that any ceramic piece can be taken for thin section analysis. Actually, you have to define the problem, and the sampling strategies will depend on the problem, which is very important. So, then only you can select the representative sample, because the sampling strategy will be extremely dependent on the problem, because I may select samples in a peculiar way for some particular objective. For some other objective, the sample collection method will be slightly different. Then mapping of clay sources, you will have to know what is the composition of different clay sources which is there within that area. Maybe, if possible, within 10-kilometer radius circle, because 10-kilometer radius area is the easily accessible area for those people. Then you will have to understand the geological formations, because clay is basically a weathered product of the rock. So it contains all kinds of fragments of rock and also the mineral components which are present in the rock. Then you need to look at the drainage pattern of the area, because this drainage pattern or the river or the water bodies, they are the ones which are distributing these sediments all around. Then different stages of thin section studies, you have the sampling strategies, then method of preparation, which is a technical work that you have to cut it and cake it in, say, Lakeside 70 cement or 70C cement, and cook it for some time, and then keep it for 24 hours, then polish it and make it transparent. Then you look through the microscope and interpret the results. This is a microscope which I've been using in Baroda, and this is Dr. Vinod. He is looking at the thin section. He has done his PhD on Harappan ceramics from Bagasara, and he used thin section methodology extensively for his work. And here, when you look at the microscopic analysis, what do? You first of all, you look at the mineralogy of the sand particles which are present there. And that is done in plain polarized light and also in cross polarized light. Then you look at the texture, that is the grain shape, grain size, frequency, degree of sorting, and nature of voids. These are all the things, that is the shape of the grain, its size, frequency, because all these things have something to do with the selection of the material. And then that is the one that determines the fineness or coarseness or the medium texture of the vessel. So this has to be understood. Then orientation of the non-plastic inclusions, if you are sure that it is 100% wheel-made pottery, and if you want to establish that. Now, this is one of those thin sections. Here you can see different types of minerals. You can see quartz, you can see augite, and you can see calcite. Here you can see a plagioclase feldspar here. So you have different types of minerals, and what you do is that you look at these minerals and try to make a kind of rough estimate, actually, what is the percentage of each one of it in a section, and what is a percentage of it, or how the percentage varies from one type of ceramic to another type of ceramic. This is the same, another kind of section that I am showing. Here you can see, when you look the previous one, you can see these are all taken in the same magnification, that is 2.5 millimeter square is the field view. And here you can see the same kind of magnification, but different types of pottery. You can see how it looks different. The right-hand side corner one, you have some kind of longitudinal particles taking a parallel orientation. And also there is a red patch in the middle. That is this one. This is called a grog, because this is actually a broken pottery is crushed and a small fragment of it has got into it. Who crushed it? Whether the potter crushed it or it was, it broke down due to certain other reasons, we do not know. How do we say it is that its mineralogy is extremely entirely different from the surrounding, and also the orientation of it is very different. Then this is to do with the orientation of the non-plastic inclusions. You can see that these are all oriented in one direction. You can see this. So this orientation has something to do with the technique of making of the vessel. Now, here it becomes slightly important, because this is quantifying the ceramic microstructure. You need to quantify it, then only you can know which is some dominant mineral and which is the less dominant one. So based on that, you can try to determine the provenance. Now, the problem with Indian material is that most of our sites are located in the major alluvial areas, which have been bringing a lot of discharges from several sources. If you look at River Indus, or if you look at River Sabarmati, or here if you look at Narmada, or if you look at Ganga and all those rivers, they're the length is very long, and also there are many small streams joining them, and these are all joining from different geological formations. So what do you get? You get a mixed mineralogy in that. So unless you have a contrasting geology, you cannot determine the provenance. But here we get a kind of mixed mineralogy. That becomes a challenge for a person who is looking at the thin sections, and when he is trying to interpret it, becomes a very difficult task. So that is one of the reasons why we are quantifying these minerals and non-mineral phases. When I say non-mineral phases, there are certain things like these grogs are there. Then you have bioclast material, that is shell materials and all those things, which is very commonly found in alluvial regions. Then you have argillaceous inclusions, which may be claystone or mudstone or something of that sort, which may get in there. So, and voids are also there. Voids can be due to many reasons, like they may have used some vegetable inclusions or something, like while they were mixing it, and when they were baking it, it got burned away, and that left out some kind of voids. And also one more thing, which is generally not acceptable, because when the person prepares a thin section, there is a possibility that there can be grain fallouts. But we know whether it is a grain fallout or not by looking at the grain shape of the void. We can recognize that. So that also becomes, because preparation of the thin section is not an easy job. Then you try to quantify the texture, that is grain size, grain shape. And for you looking at the grain size, we use the kind of grain size description that is given in sedimentology books. And if I look at it, anything that is less than 60 micron, I consider as silt. 60 to 100 micron, I consider it as very fine sand. 100 to 200 microns is fine sand for me. 200 to 500 micron is medium sand, and 500 to 1000 micron is coarse sand. So by looking at the dominance of that, you say that, okay, this particular ceramic is tempered with fine sand or medium sand or coarse sand or silt tempered ones. That is how it is done. Then we try to do it using manual methods and point counting. When I was doing my PhD work, I used to count the whole grains in one tin section. That used to go up above 10,000, sometimes 15,000 and all those things. But then there are better methods, because afterwards it was, because I did not know much about that. We were not getting any kind of inputs from other people, but now we have several other methods. Now, manual method is by visually comparing the overall grain in with the field of view, and it can have high error. Then point counting is done with a kind of instrument called Swift automatic point counter. You can set it to single jump, double jump, and triple jump, and anything of that kind, and less error. And 2.5% is the maximum error that one can, my error is 2.5%. That is error. I do not know, because you will have to find out what is the error of the analyst. Now, this is one of the techniques that has been developed by, actually, this is Matthews. It's 1985 British Museum occasional paper publication. And that is missing here, actually, that courtesy is there. This is not somebody else's work. So anyway, this is actually what you can see is that it is 0.5 to 3 millimeter size grains. And in this given area, if this is the way it appears, it means it is 10%. And if this is the way it appears, it is 20%. This way it is 30%. This way it is 40%. When I was doing it, we did not have this facility. So I had to imagine that if I push all those grains to one side of the circle, or one part of the circle, how much area would be occupied by that? So 10%, 15%, 5%, like that we used to do. So this is another grain size, and 0.5 to 1 millimeter. So this is 30%. You can see this is also 30%, this is also 30%, this is also 30%. But the size variation is there. And if you push it to one side of the circle, it occupies 30% of the circle area. This is also from Matthews. Now we have an instrument called point counter, I said. There is line scanning, area scanning, and point counting. So this is actually the first one. This is the one which is point counting, which you also do here. That is, you have the crosshair, and when you move the stepping stage, and the stage, when you move it, if it comes under the crosshair, you measure it. And the second one is line. This is line, and sorry. This is line, and this is area, and this is ribbon method. I generally follow this point counting, and when you have 300 points, and you try to see what is the grain matrix ratio, and also within these grains, you try to see what is the minerals, what is their percentage, and what is their size, and etc. etc. All those things can be studied. And this is again from Archaeometry Journal, and this particular, the courtesy part is missing. This is Middleton et al., 1985. And again, this is a microscope and the stepping stage and also the point counter. Now we come to petrofabric. And what is petrofabric? That is, this is the definition of petrofabric. It refers to the overall composition of the ceramic piece, and it includes mineralogy, texture, voids, frequency of inclusions, degree of sorting, and orientation of particle. All these things have to be separately recorded. When clubbed together, you get a group, that is petrofabric group. You may call it as petrofabric group A, B, like that, or petrofabric group 1 or 2, something like that. The process that is involved in this petrofabric characterization, what are the things that we do? One is that you look at the features of the clay matrix, the color matrix, color, optical scale, compactness, bioactivity. These are all the properties that we look at. Then you look at the non-plastic inclusions. These are all the properties that we look at. And then more mineral process, you look at the voids, loads. Then this is one of those photographs. You can see the difference, actually, color, optical. You can see this. I just kept it here to tell you that there are two different types of images, and the difference in these two different images is the mineralogical difference is there, the size of the grains is different, the orientation of the particle is different, and also the matrix. The matrix is the medium in which all these things are there, and its color is different. Its color is different means that is an indication of the kind of firing that has been given, because if it is extremely highly fired, it will have iron oxide will give a different color, and if it is lesser fired, it will give a different kind of color. Then there's another one. Here you can see this is a bioclast material. This is a shell or something of that sort. It's a rock fragment. And then you have a lot of other kind of bioclast material. And recently we have been seeing phytoliths also in some of those ceramic tin sections. Actually, it happened to come there because it was a part of the alluvial clay. That is how it came there. And this is an indication. Actually, from here, what you can do is that by looking at this, you can look at again. I'm repeating provenance, technology, cultural process such as trade and exchange, all those things can be done. This is how the texture analysis is done. What you are seeing is that this is one of the old works actually. Here you can see that the mineralogical variation is plotted along with the size of the grains actually. That is, you can see here there's a silt silt, all these grains, you can see what is it actually. And in this one, I want to say something because I did a lot of ethnographic studies. And when we were doing ethnographic studies, um, after doing this textural analysis, I found that two dominant peaks were coming. So whenever they were adding sand into it, it was giving a bimodal distribution pattern. And when they were not adding any kind of sand, only sieving or something of that sort, it was a unimodal distribution pattern that was there, it was giving. Again, the petrofiber characterization actually, the you see something which is very important. Actually, the methodology is a bit boring. I know that. So the number, nature, closed or sealed pore, then all these things have to be taken into consideration when you are doing the petrofabric characterization. Now, what do you do out of this? Once you do all these kinds of fabric groups and all those things, what is it? How are you going to relate it with the other kind of archaeological these things? So here, when what one of the options, first option is that you can relate it with the conventional wear categories. That is, archaeologists are making classification of ceramics. They are making it in red ware, buff ware, gray ware, black and red ware, etc., etc. And that is based on the similarities and differences. And now we can examine whether there are any similarities or differences are there in the paste of different wares. That is one of the things. And if at all you have it, that is the technological relationships can be understood. For example, I can give you when you are looking at two sites and when you have two resembling kind of ceramics, if the mineralogy is different, you can say that the paste preparation technique was the same. So that is an indication that probably some kind of communication was there between two communities in terms of technological transmissions and all those things. That is one of the things that you can. So varieties of paste recipes you can understand. Then the mode of production, that is specialized or non-specialized technological tradition. This is also something I will explain it a little later because I need to speak about the ethnographic work that we have done. Then when it is related to the stratigraphic distribution, you can see how the technology was evolving over a period of time and what were the changes happening in the paste preparation technique over a period of time. Whether there was any new technique experimented or new technique was involved in that one, or some of the techniques were forgotten and left out. All those experimental stages one can get. And when you are trying to look at the functional difference in manufacturing, how the raw material was manipulated. For instance, when you are looking at the cooking vessels, that is the handi, common handi types, you come across minerals which have a coefficient of expansion which is very close to that of the clay. So as a result of which, when you are heating it continuously, because cooking vessel is heated 10 times, 15 times, 100 times for a few years, days, months, and all those things. So it doesn't break because always it is getting heated. And it has thermal resistant materials within that. Some of the minerals like plagioclase feldspar, calcite, basalt fragments. These are all some of those things which can act as resistance to heat and which will not allow it to break. Now, this is when we started working on this fine ware ceramics, it was very difficult because we had to have our own methodology. So we had to develop a methodology for which I conducted some ethnographic studies. And all these samples from all these stages were collected. That is raw clay, then whatever the preparation techniques they were using. So from different stages of its preparation, then the formed vessel and the leather hard stage, and every stage of it, they were thin sectioned and they were studied and they were used as a control sample to make the interpretation. Because there, what you can see is that you can observe how the potter works and how the distribution of the grains take place in that one. Then you can so then you can see how it gets reflected, how all these processes are translated. So for which I did study, I must have studied at least several potters from northern India, southern India, western India, eastern India. I haven't studied. Then I have also worked with potters from Sri Lanka. So overall, some kind of idea is there. So collected these samples and tried to see. From Western India, I must have studied at least 10, 15 potters. And southern part, maybe around same, 6, 7. And northern India, 2, 3 sites. So that has given me some kind of idea about how does this process get translated into a thin section. Now, these are all the ethnographic studies that we have done, and you can see the clay is getting collected. And then there are two types of clay here. One type is quite hard and thick, and that needs to be broken. You have to use a hammer and all those things. And then here you can see this is sieve. This for sieving, what they do is that they have a sieve which is made of bamboo reeds, and they are sieving it. And behind that particular sieve, this is a sieve. What I am saying, this is a sieve, and behind it, this fine clay is getting collected. It is mixed with water, and then they keep on kneading it. Kneading is done with hand. Kneading is done with foot, and then it is thrown. And this is the maximum size that these people take. Then they enlarge it. Then the vessel is taken out, and it is this particular point. Here it is a pole like thing, and that is joined with the help of this uh, anvil and this paddle and all. Then he's enlarging it, and these are some of the tools that he is using. Then he is painting it, and this particular thing is slightly important because you have paddle impressed pottery from early historic period and also even in Neolithic period in some of the sites. Then this is a kiln. It's an open fire baking kiln, and this is a closed kiln. And these are all some of those kilns that we have here. What is important, what you need to see is that there is reuse of pottery. Is there actually broken pots and all those things are kept here and in a row, and then they are covering it with. They are keeping it like this, and then a clay coverage is done, and then it is baked. And this is another kind of kiln. It has a capacity to accommodate a large amount of vessels. This is quite popular in southern India, that is Tamil Nadu and southern part of Andhra Pradesh, and also in Sri Lanka. Now, after doing this exercise, they were sampled. The thin sections were prepared, and these are some of those thin sections from the experimental stage. Now, this is black clay, and this is and here when they were mixed, this is the way it was done. And this is the base of the vessel. If you look at it and you will look at it, you will say that this to the same vessel. The current essentially but here, visually it looks important. But when you do the overall analysis of it, you want to just texture it. And then these are all the changes. So I have samples like this. That is samples of different stages of preparation of clay paste, different types of preparations of clay paste, and then based on that, a kind of standardization is done, and they were used. Now I don't have those samples with me. Something unforeseen happened. I don't have it with me. So they were used as reference samples to speak about the kind of changes that have been happened to explain what exactly or to explain the ceramic thin sections. Now, this has to be linked with culture, otherwise there is no. So while doing this kind of analysis, actually this ethnographic analysis, and also when I was trying to combine it with many times, so I noticed that this is the way that it is it is happening. There is household production. That means they are probably part-time specialization or occupation, low degree of standardization. Some of those sites, which recently I analyzed some of the sites from Eastern India, that is Northeast, and it has very low degree of standardization and probably indicating a household production. And then there is also a non-centralized production among the porters, porting community, that is part-time specialization or occupation. You can see moderate degree of standardization, and then centralized production, incipient to full-time specialization, high degree of standardization, administered production, full-time specialization, high degree of standardization. Now, how do you measure this? How do you say that? This is again a key area. And I have this several methods. Then you have a full person, check the value. Before they do that, go harder to regular talk. And keep up. They are going to be before the smoke the mouth. I'm going to explain it. So when it comes to this question, so because in the state you know that the bounds from the right side, the maximum of the and that is but when you look at the other side of this animal where you know things happen in this test. So here it is mostly household production means you can either animal or fish more and they have a low degree of standardization. Then non-centralized production. Because there is some kind of control that you do. So, and there is an so there, such kind of thing, what you see is that moderate you do see, or if you measure all of them, or if you try to see the spectrum of one of them, there are local similarities. There are no similarities that, but I think what I'm saying is that most that we have to. And then it comes to the centralized production. I would say that something like that is centralized production. But you have as well as the most that you have to spend. When it comes to only context perspective, you have to search the sincere and that is that one context. So this thing done with economic and then we also know how to look at the kingdom of the so like we cannot get the honey and then you try to see what is the variation of what is the variation of what is the variation of This is one and we're going to go this is something that we can So I'm sorry about from where they could not hear. I can continue. So the second site, this particular one, it is located very close to a lake, which had some kind of clay deposit in that one. So that clay deposit was also analyzed, and that clay deposit was, from the composition of that particular clay was found close to this one. So we could say that that was the provenance of that particular settlement. The most of the ceramics that I analyzed were from there only. That was a trade center. Whereas in this place, actually, it is not like that. Now, here, what you do is that you look at the geology and also you look at the drainage pattern. So one of the sites which I analyzed that was coming here, the first one was coming here, and that is falling within the central Gujarat alluvium. And if you look at the geology of it, it has discharges coming from all these Precambrian formations and also these Deccan Trap formations here. So it has a very mixed mineralogical composition. Whereas the second site falls somewhere here, it is its mineralogy and all those things are more or less very close to the geological composition that is there in that region. Then I'm showing you another site. This is also a published one. This is Birana from Haryana. And these are all the kind of ceramic identifications done by the excavator late Dr. L.S. Rao. You have different types of ceramics that he has. And they were thin section. And I found several groups. That is group A, B, C, D until group J. And some of them had subgroups. Now, this grouping and subgrouping, this is a very interesting kind of technique. Group and subgroup will have the same mineralogical composition, but there will be lot of textural variation, indicating that perhaps the process with which the clay paste was prepared was different. So clay paste preparation, because these potters are very orthodox. Actually, it comes to them through hereditary. They pass on the knowledge. They teach their children like that. So one technique, it becomes more or less their monopoly. But if suppose somebody else is collecting clay from the same source and making it in another way, so its mineralogy will be same, but the texture will be different because their tradition is different. So that is what is that is how I interpret this group C and C1. They're compositionally they are the same, but texturally they are different. Then, by measuring the grain size and all those things, I found there are three categories. That is silt, very fine sand, medium sand, coarse sand. That is the nature of the tempering material. So here you can see that is silt plus very fine sand. This is ternary diagram, and based on these three categories, you could say that there were three different traditions of vessel making in that area. There may have been more than that. I'm not denying that. But from my samples, the analyst sample, I could identify three. This also falls in such a strange area, very difficult area here. you have a very complex mineralogical formations. You have the older alluvium and the new alluvium there. So it was impossible to make the provenance analysis by looking at the mineralogy. So what was finally done is that based on the susceptibility of the ingredients to weathering, actually degree of weathering of this material, based on that, the provenance were determined. And these are there are three areas from where, or three different compositions I have been able to see. Now, where are these areas? I do not know. I cannot pinpoint that area, but I can say that there were the ceramics from Birana, they belong to three different kind of traditions. Now, this is another type of vessel, micaceous redware, which is found in association with the Indus Valley ceramic types in Gujarat. Actually, this was S.R. Rao had done lot of, he had collected lot of this material, and this is a distribution of overall distribution of this micaceous redware. And interestingly, most of them are bowls, and don't have a very regular surface. They have an undulatory surface, which means that they are either handmade or made of mold. And then that is one thing. And second thing that you see is that the kind of paintings that is done on it, they are also different. Actually, it is not regularly executed. You cannot see that it is getting, flowing down and all those things. You cannot see it. Then it was studied actually when we were looking at the texture and also the technology part of it. In comparison with the other, they were falling in one particular category, one specific region it was falling. So by looking at it, the overall, this is a micaceous red where you can see the difference. These have larger grains and they are also having large grains. And here there are finer grains. So there is entirely different process of clay paste preparation. Now, if you look at it, petrographic studies, and this micaceous redware, actually from the surface studies and all those things, it is handmade or molded or made on a slow wheel. And it has a burnishing, it has a thick, glossy surface. And when you look at the Harappan pottery, it is wheel made or multiple techniques. It has a regular slip, and sometimes it is unslipped, and it has variety of shades and fabrics. Whereas this majority of the micaceous redware vessels are round bottomed. It's not the flat ones, round bottomed ones. And the execution of designs is different in this one. And also the composition, it is different. So I tend to call this as a handicraft style, and the other one was as an industrial style. So you are able to recognize two different types of styles. Now, this is the last slide. If you ask me what exactly is the future prospects of it, see, you can identify raw materials, sources, and all those things. But thin section analysis is just one method. You have to use multiple methods. You may have to use thin section analysis along with some other kind of chemical analysis methods and combine the results and see it. And you can see the patterns of exploitation by different communities in the past and the concept of economy and all. Then studying various levels of standardization, that is, you can reconstruct the organizational aspects of production and distribution, which is quite important because some of the vessels travel a longer distance and some do not travel. Sometimes the tradition travels to a longer distance and the vessels do not travel, or the idea gets transmitted, or the technology or the manufacturing process, the tradition goes. We had also done some kind of work, ethnographic studies, and how the traditions move. The tradition moves through marriage relations also, because female porters and male porters, they marry from different places, and some of the traditions they get. And then in certain cases, some of the porters are very orthodox. They will not accept any tradition that is coming from outside. They want to retain their own tradition. So the girl or the boy who comes this side, he has to follow the tradition there only. And I know a porter in Baroda who gets Even today, he gets it from the Ganga Valley, the clay, because he is a migrant from Ganga Valley and he cannot work with Baroda clay because they are very particular about the raw material. So raw material also travels. It is not only the vessel or the technology, the raw material also travels. Then you can try to look at the social and economic stratification based on the overall ceramics. And then it has to be linked with the other archaeological finds. And then role of superstructure in promoting the craft specialization, and it could add as an important component. I know I want to say something. See, you may come across whenever you are doing, because in many of my studies, I have noticed that unpublished ones, because there are many authors and all authors have to agree, then only it can get published. And some authors are not even replying. If any of those authors are sitting and listening to it, please reply to me. so, so what is happening here is that actually there are many interesting things, like there are multiple geological sources and multiple techniques in certain places, in certain sites. Then certain sites have only single geological source and multiple techniques. And there are also some sites, very rare case, single geological source and single technique. Then multiple geological source and single technique. So I have examples of all those, but these are all done for students who have been doing PhD and all those things, and they have to publish it. So I cannot publish it, their work. Thank you very much. If you have any questions, please ask.
Okay, the question is, the related ware found across India, particularly in eastern and southern India, are considered as indigenous origin. The related ware, what is your opinion based on scientific analysis and studies?
Thank you for asking this question. I have also done some related ware analysis. I have not included it in this one because a part of it is published, but there are more samples which are still unpublished. Now, I followed thin section methods, and I found some 3 different sources. I had got 3 different sources. One source was actually I analyzed pottery from Anuradhapura, and there were 1 or 2 specimen whose mineralogy was no way agreeing with the mineralogy of that Anuradhapura region. These are all very fine shards, very fine grains in that one. So they were not agreeing with that Anuradhapura mineralogy, but they were agreeing with the related ware samples, thin sections, its composition, which we got from Petra in Jordan. So there is one set which is, from somewhere from outside. And the Ganga Valley ones and the Anuradhapura ones, they had some kind of close relation. Okay. So that is some kind of close relation was there. Now, there is a problem with related ware because there was lot of things have been spoken about related ware, because when Wheeler made a statement that the better ones were brought from the Hellenistic world and the cruder ones were made here, which is not correct. Actually, we have also very good ones which were indigenously made. And I'm sure that there were more than 3 or 4 centers in the Indian subcontinent. I'm using the term Indian subcontinent because you can include Ganga region, and also you can include southern India. You can also include Sri Lanka. So there may have been 3 or 4 centers where it is made. It is primarily the technology was spreading, and particularly the paste recipe was also fully accepted, and the potters were able to make it. You have different compositions. On this, Dr. Gokte has also done some X-ray diffraction analysis and all those things. Is he happy with my answer? Ask him.
Okay, let's see. Maybe he'll comment later. If
Yeah,
he doesn't, I'll type to him. So the next question is by Chaitanya, who asks, what kind of analysis is used to study thin sections? Is there the use of XRD or XRF involved?
Thin section is primarily a microscopic study. You prepare a transparent section of a ceramic piece and see it in a polarizing microscope. And you see it in two different conditions. One, you see it in plain polarized light, and you see it in cross polarized light. And there what you are seeing is that you are looking at the optical properties of the minerals. And that is what you are seeing. It is a visual analysis. Whereas XRD, what you do is that you powder the material and then you scan it for a particular 2 theta, maybe from 2 degree to 45 degree, or some people do it from 5 to 90 like that, and determine the peaks and all those things.
Okay. So this next question is actually, it concerns that part which the audience could not hear, the online audience. So maybe I'll come back to that in the end,
Yeah.
and because it concerns the administered production versus centralized production. So I'll come back to that later, but I'll take up the other questions. Arjun asks how the pigment on ceramics can be studied with mineralogical approach. Can it be suitably studied with the thin section?
The pigments,
The pigments on the ceramics, can they also be studied?
the paintings,
The colors,
the paintings, color. Okay. So if you have some very good machine with which you can prepare the thin section, and if you can see to that the external coating doesn't disappear, you can use that. Otherwise, the best one is, whatever I have done is that a combination of EDX and SEM, that is energy dispersive X-ray analysis and scanning electron microscopy. So what you do is that you look at the scanning electron microscopic image and you focus onto specific areas and you analyze them. So there you can see the slip portion, you can see the pigment portion, and you can also see the core portion. So 3 areas can be analyzed separately, and then you will know what exactly leads to the color of that particular material.
The next one is by Prasanna Ghalsasi from MSU Baroda.
Okay.
The question is, can you comment on the historical development with the formation of homogeneous pottery and the presence of grog? So he explains that grog is related to reuse, and it is a new concept. GROG, grog.
Yeah, I showed grog in one of my, and the issue is that I've been seeing grog right from the lowermost levels. Actually, I have got it from Rabi levels at Harappa, Rabi phase at Harappa, and we do not know how did it come there. And I've seen it in almost all Harappan ceramics. Then I have also seen it in this particular, actually, early historic materials also. But his question is not very clear. He wants to know what evolution.
The historical development with the formation of homogeneous pottery.
Homogeneous pottery. What is homogeneous pottery?
And
I'm talking about the microstructure of the pottery. So in that one, this is added as one of the ingredients. Either it is added or it is present there, because it is all happening in a potter's workshop. There are vessels are made there, vessels break down there, vessels get crushed down and it becomes dust, and the dust gets into clay and all. There are many ways in which it gets in. Now, if you ask potters whether they are adding it deliberately or not, some potters say that yes, we do not have sufficient amount of sand and to and to give it a strength. Then we crush it and put it. Some potters have the habit of bringing calcite nodules and crushing it and putting it in there. But then at the same time, accidental intrusion also is there. So one doesn't know how to separate it out. And the homogeneous development is something which I'm not able to answer, because it is more or less heterogeneous rather than homogeneous.
Okay. Next question is from Ibrahimul Bari.
Sorry?
Ibrahimul Bari.
Okay.
He's asking the question, can we find the changes in the composition of minerals after burning the ceramics? So he uses the word metamorphosed.
Okay.
Can it hamper the role of finding the provenance?
Finding the?
Provenance, the source.
See, it's a very tricky question actually. No. quartz undergoes transformation when you heat it. Okay, tridamite, cristabalite. Similarly, calcite becomes galenite, diopside, and all those things. Similar minerals also exist in nature because some high temperature formations in metamorphic rocks also it exists. So if there are certain mica under, its color changes sometimes when it is heated. So, but then the same kind of mica also exists in nature. Now, this can be done if we have to make sure that you do not have any of these kinds of minerals within that vicinity in the geological formations of that is assumption number one is that the material is made there only. So you need to see that whether this particular material is not naturally occurring within that area. And then if we are heating it, but these kind of transformations changes require at a high temperature, that is somewhere above 700 degrees Celsius. And if you heat pots to above that temperature, then it won't stay unless you have this kind of Chinese and all those materials, they are heated to very high temperature. But then the kind of conditions through which they are heated is different. So I haven't come across any of these things, but there are certain works that these transformations of the properties of these minerals over these transactions of British Ceramic Society, it has given a lot of articles. There are a lot of articles in that one. But I haven't come across any such kind of changes in the pottery from India.
So just briefly going back to the previous question where you asked what does he mean by homogeneous production? He just explains here, Prasanna, who asked the question, that homogeneity on the basis of even distribution of particle size, and you talk about it in slides number 17 and 18.
Even distribution of particle size is, that means he will have to calibrate it actually, because if you think that 80% of the particles have the same shape, same size, same alignment, same orientation, then we can call it as even distribution. You will not get 100%. That is it. Because there is a lot of heterogeneity in the ceramic thin section. And you have at least, you have, even if you take a unimodal kind of vessel, you have at least 3 to 4 different sized grains in that one. So they give an overall one peak. So it may look homogeneous, but it is not homogeneous. It is heterogeneous. And homogeneity is there in the external attributes. Note, this is the internal attribute that I'm looking at. External attributes like designs. You can have, designs or natural motifs. You can have, that is straight lines. You can have cross lines and all. There can be a homogeneity. But at the composition level, homogeneity is very difficult. We think that homogeneous mixing is done. That is why the process of kneading and all those things, which the potter does, it is aimed at, distributing the minerals and the sand particles in a homogeneous way. But there, homogeneous means it is present everywhere. But when you look at the grain size and grain shape and the frequency, a person like me, I cannot say that it is homogeneous because I have to make a statement based on the data. There is heterogeneity I'm seeing there.
The next question is from Swayamdipta Munshi, who asks, how should we study fine fabric thin section potteries?
Who is this?
Swayamdipta Munshi.
Okay.
Do you know this person?
I can study, but if she's a beginner, it becomes a bit difficult actually, because you will have to, standardize the method. She will have to calibrate it. First of all, she will have to go and sit with the potters and learn how they make the fine wares, and then collect samples from each stage and prepare sections of that, study it and define them, and then try to see it. It is possible.
Relative answer. So the next question is from, I guess it's Professor Cherian. It says Pama. From Pama. Someone from Pama, and I'm guessing it's Professor Cherian probably. At Pattanam site, the vast majority of the pots were bowls. some
What?
70 bowls. They were bowls
Bowls, yeah.
at Pattanam site. Most of the ceramics were bowls, some 70 to 80%. All were of moderate dimensions, which could have been used daily for daily purpose, which could have been used daily for daily use other than cooking. So, what are your reflections on this? That majority of them are bowls, but they may have had uses other than for cooking.
Actually, my answer is slightly different because we have a concept that one particular vessel is used only for one function. It is not like that. It is multiple function. All right. So bowl may have served as a drinking vessel. It may have served as a serving vessel. It may have also been used as for eating food and all those things. See, I can give an example. Like if you look at these pastoral nomads who are here, and they have only one bowl when they carry, and in that one, they drink milk, they cook food, they eat it, and vessels have multiple function. See, when we look at it, we are looking at it from today's point of view. In my house, I don't eat in a pot. I eat in a dish because that is a practice we have been having. But then there are houses where people eat within the pot also, because it all depends on the the kind of the function of the vessel. We cannot make it out from the form. To some extent we can do it, but in the past, how did they do it? It becomes a slightly difficult thing. Actually, Pama is a organization in Kerala. What they can do is that they can there are these farming lands where people go and guard in the night. They used to carry, I have seen them, they used to carry these small kind of bowls and all those things. They used it for multi-purpose actually. Khana, they were eating food in that one, they were drinking vessel in that one, they were also using it as mugs to take bath. So it's a multiple function vessels. Yeah, nomads carry very less variety. Actually, they don't carry they have one large pot in which they carry water and also one cooking vessel and one bowl.
The next question is by Dr. Arslan, who asks, can you please comment why a specific pottery type like the flanged pots or flanged pots of early Harappan phase have different percentage of inclusions in different specimens?
Can you repeat that question?
Why a specific pottery type like, how do we pronounce this? Flanged or flanged? Flanged pots of the early Harappan phase, they have different percentages of inclusions in different specimens.
Okay. Now, there is a relation between the function of the ceramic and the kind of inclusions that are added. So when I was speaking about the cooking vessels, if you look at the cooking vessels, invariably you find minerals whose coefficient of expansion is very close to that of clay because it has to be heated many times. So it should be shock resistant. So that function and the vessel function and the kind of inclusion, there is a relationship. When you are looking at the large jars, the kind of inclusions that you find them in that one, they are all coarse grains. And when you look at the thin vessels, the kind of inclusions that you see are very, 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 very fine kind of grains or very fine kind of sand particles. So that is a relationship. So this particular kind of flank vessel, whatever the kind of vessel that he is saying, so what its size, its thickness, its shape, its function, all these things determine to some extent, if it is a specialized product, to some extent, all these things will determine the kind of material to be added to that. Clay paste preparation technique will depend on that. That is how it is.
I see a very interesting question on NBPW, so I'll take that first and then I'll come to the
Sorry?
On NBPW.
Okay.
So this is a question by Madhurima Bakchi, who asks, NBPW found from Takshila and NBPW found from the east, like Chandraketugarh or Mahasthangarh. These are under different types of geological areas. Then can we differentiate the technology also because they are from different geological areas, or it was, or these areas adopted the same technique which indicates the centralized market zone?
It can be understood. You need to use multiple methods for that. You will have to look at intersection analysis. You will have to look at X-ray diffraction. You will have to look at other compositional analysis. So all these things, once it is done, it can be understood. And then prior to that, if at all it has to be done, the semi-quantitative analysis of a total number of NPPW which is present in different regions, that needs to be, we need to have that number. And we also need to have the associated portrait, because you cannot study just NPPW in isolation from the other ones. So the other materials also have to be kept as reference samples. Other ways also have to be studied. Otherwise, doing thin section analysis or any kind of analysis is pointless, because you will not get it. You need to have comparative analysis there.
2 or 3 more questions. The next one is by PC. I think it's Parth Chauhan, maybe. I don't know. So it is abbreviated as PC. During firing, there are changes which occur in the mineralogical composition of the pottery. Therefore, when we correlate with the geological settings, what are the points we should take into consideration?
During firing?
There are changes that may occur in the mineralogical composition of the pottery. So when we correlate with the geological settings, what are the points that we should take into consideration?
We should take into consideration whether while firing, whether the mineral has undergone any kind of change or not. That is one thing. Second thing, we need to see that, because these minerals also occur in nature. And those samples have to be collected and see that how the optical interference take place in that one and how it is visible here. So that properties also need to be compared, because as a result of heating, some other kind of things may come up. For example, if you have this chalcedony, if you heat chalcedony, it turns into yellow color and it turns into red color, something like that. Similarly, it can happen here, but then the chances are very less, because that temperature is not, we don't take it to that temperature. Because if you look at this open fire baking kilns or closed fire baking kilns, they say that it goes up to 800 degree, 900 degrees centigrade, but it doesn't happen. That much temperature, it doesn't go. In certain kilns, it go, but then there are several other precautions taken there.
Okay, yes.
At this point, when the mineral is heated and it resembles something which occurs in the nature,
Yeah.
There is something called elemental analysis.
Hmm.
If elemental analysis will also change when you heat, and it will also be comparable.
No, elemental analysis, actually the problem is that, for example, if it is quartz is silicon dioxide.
Yeah.
Cristobalite is silicon dioxide. Tridimite is also silicon dioxide. So how will you?
But in addition to silicon dioxide, there may be other rare elements, in the mineral itself.
No, you are talking about a mineral, or you are talking about a sediment?
Mineral.
Mineral. In that mineral, quartz is silicon dioxide.
Why?
So
It has only SiO2, nothing else? No other element?
No, because if you have some other elements in that one, then the property changes. It ceases to be quartz and it becomes some other mineral.
But one is
because every mineral has silica. Every mineral has silica. Every mineral has silica and alumina.
Yeah.
Many of them have alumina also.
Sure.
So that you will be getting that composition. You will get, if you, feldspar, for example, iron, silica, alumina. So you get composition of all those things. But how do you know that it is coming from this particular feldspar?
Not
You will have to analyze, pick up that feldspar and analyze it there. But if you crush the material and analyze the powder, then you will get everything. You get a bulk analysis sample.
The next question is by Rohini. And she asks, how far thin section analysis will be useful for the study of porcelain? And how can we study
Will be difficult, because actually porcelain, I have seen, I had a student who was working material which is very close to porcelain. And some of the samples he had analyzed, nothing was visible actually. It will be a bit difficult. But then if it is a coarse porcelain material, it may be possible. If it is fine porcelain, then it will be difficult because it's fired to a very high temperature, and also the mixing of materials in porcelain is different.
Okay, last two questions. One is by Dr. Umesh Kumar Singh. He asks, is there any relevant methodology for understanding the functional analysis of pottery?
He wants to know the functional analysis pottery. That is actually
Any methods, specific methods for the functional
specific method. That
analysis?
is there is a very big branch called residue analysis of pottery, and there are residue analysis of pottery is that itself requires 10 hours lecture because there are multiple techniques used, multiple methods are there because there is a lot of standardization that needs to be done. So, and extraction of the residue from the pores and all those things is also very important. So residue analysis is one of the ways to confirm that this particular vessel was used for that.
The last question, I come back to that part which I think some of the audiences, they missed out because they could not hear you clearly. How do you differentiate between centralized production and administered production? Or maybe she means household production. Anyway, so could you please explain those differences?
This is from whom, the question?
This question is by Coel Ray.
Right. So, actually, the story of this particular slide is something, it's a combination of lot of ethnographic work, lot of ethnographic observation, and then trying to see it from archaeological context of view, archaeological ceramics point of view, then trying to get into the process of it. So for the first one that was done was different areas, ethnographic work was done. So household production, that is a part-time specialization. Basically, people who are making this kind of chirag, that is one of the examples that I can give. Chirag, that is Diwali season, they make it. They are not professional potters or anything of that sort. What they do is that they mix clay and they press it and they make. And they, it's a part-time occupation for them. Then after some time, they get into some other kind of work. So that is one of those examples that I can give. Then it may not have any kind of standard because that particular vessel, unless nowadays we have even like of molds are available. So what they do is that they bring clay, then make a kind of flat, like a sheet. They make a sheet and they keep it, press it and take it out, and you get all those designs and all those things. So that is one of the things. And then it doesn't have any kind of standardization because the size can go here and there. Designs will be very different. If you take two and if you look at the designs and all those, there may be similarities, but then also there are differences and all those things. And the kind of treatment that is given to the clay, it will vary because it is quickly made. That is one of the things. Second thing that I can give you is that there are certain temples in Gujarat. Don't compare it with the Puri temple. There are temples in Gujarat where the offering is given in clay vessels. That is known as Ram Patra here. That is, and that is not fully baked ones. And it is partially baked. It can retain the shape. So you give the prasad in that one. That is a second type of household product. And that is actually done by many people. And they don't do it full time. They do it only half time because I may do it for about 2 or 3 months. Then somebody else will do it for 2 or 3 months, something like that. That is one. Non-centralized production. That is another thing that for this actually, what we did is that I was trying to understand how the clay raw material exploitation was taking place and whether these people were connecting themselves with the raw material and whether they were connecting themselves with the future generation, future potters and all those things, how they were taking precaution in extracting it. Is there any kind of sense of economy in them? Because if you exploit the raw material fully, what will happen to that area. So that was actually, it's a bit complex kind of thing, because I will require at least 1 hour for doing that, and we need to get into archaeological theory a little bit and ethnography and all those things. Centralized production and administrated production. Centralized production, okay, she may be under. Administrated production is my own creation. Because when I was working with this sintered research slipware, it was different. So it was different, and specialized potting is there. Specialized potters are there, and my potter during the Harappan days who made this sintered research slipware, he was a specialist potter. That is how I made it. And even this, the people who are making this NBPW, or people who are making this NBPW, there are varieties of it in NBPW. It's not necessarily always black. There may be golden ones, there may be silver ones. So that are all creation of this administrative production. And now, making this particular kind of thing, it has a background. The archaeology background is examined well, and also the kind of social changes are examined. The whole archaeological assemblage is examined. The plan of that particular settlement is assessed. All those things are behind making this particular kind of statement.
Sir, one last question, which I unfortunately missed out, but this is from Professor Prakash Sinha.
Mm.
He conveys his greetings to you and asks, would you
Thank
please
you. Tell him thanks.
would you please throw some light on the average distance covered or traveled by potters to collect clay?
Generally, I have seen most of the potters, they go to 10 to 15 kilometers. That is a maximum when they go on foot, and they bring it on donkey back, or they bring it on a bullock cart. And but then this is modern times. Actually, I told that there is a potter who is settled in Baroda. He's from Mathura, and he cannot work with the clay from Baroda, so he gets a clay from Mathura. His son was trained under a potter in Surat, so he works with the clay from Surat region. If you give him the clay from Baroda, he is not very comfortable, but he still makes it. So that traveling is for the raw material on foot, it is 10 to 15 kilometers. But otherwise, there is many other things. Now, coming to the another part, that is trading of pottery, which is also there. If it is traded on land, they don't take long distance. Generally, they trade it through river, because shake is less, chances of breakage is less, all those things.
Is inclusion different from tempering?
Sorry?
Inclusion and tempering, is there a difference or one and the same? Tempering material they add sometimes.
No, actually, there are different words used for this. That is, some people use sand particles, some people use it as tempering material, some people use it inclusions, some people use the term non-plastic inclusion, some people use the term aplastic inclusion.
What is
aplastic?
Oh, aplastic.
Yeah. Okay, aplastic or aplastic, whatever you want to say. It's the same material, same thing.
It is one and the same.
Yeah, one and the same.
So in thin section, it is possible to identify which was the foreign material into the clay.
Yes, if it is a bimodal distribution, when you are doing the grain size distribution pattern, if it is a bimodal distribution, you can suspect that some sand is added to it. If it is unimodal, because unimodal means, you sieve it and the kind of grain size, there is some control coming there, it will give you only one peak. Whereas when you are adding it after that, it gives you 2 peaks. Because the sieving is done, and the sieved clay is, while preparing, they add sand into it. They don't mix it before that. So that is why this bimodal distribution comes. It's not necessary that it should be always true, but then semi-bimodal is also there. That is another thing which I have noticed.
Thank you so much. If the offline audience, if they have any questions, they can ask Professor Krishnan after the talk is over. And I think we have plenty of time for that. So I thank Professor Krishnan for his time, for this wonderful talk. I mean, it's really wonderful to listen to him every time. And listening to him, it makes me understand how complex the pottery production and how complex the study itself, right? It requires a lot of experience and a lot of expertise in understanding the ceramics, and that to look into the micro inclusions, it's going to be a very tough task. I think I should compliment on behalf of IIT Gandhinagar Professor Krishnan for his really a remarkable career and also a remarkable contribution to the field of archaeology and ceramic petrology. I thank all of you, and I thank all the participants, online participants, for participating in this lecture. And I also request them to come again next month, and we will be continuing with another talk. Thank you.